And in this class we are discussing the set union and their properties, important statement and theorem, and which I am going to discuss and vividly along with the Venn diagram. So nicely the class is going to be prepared for you, and I hope you will take interest, because these are the most important. Without these operators and you cannot proceed the knowledge of set theory, without which the knowledge of set theory will be incomplete. Understand? And any kind of problem and you are going to solve based on the concept of set theory, so these set operations are most vital for you. Okay? Understand? Let's see here, first of all, the union of set. What is the set unions? Union of set. Right? So what is the set union? Union means combination. The union of sets, two sets A and B, is set C. When you are combining two sets A and B, and it gives rise to the formation of another set, single set, a new set, that set is C, which consists of all the elements that are either in the set A or in the set B. Symbolically, the union of sets A and B is represented as, we can write A union B. The symbol stands for union. Sometimes the symbol universal set, sometimes you know all of you, and the symbol also we can use sometimes. This is the symbol stands for universal set, but this in set operation the symbol stands for union. Okay, which is the combination of two sets A and B, or more than two sets. So A union B, this is known as A union B. We read as A union B. Okay, and we can represent in the builder methods A union B, which is equal to X, such that X belongs to A or X belongs to B. Clear? Understand? So this is the builder methods. In the builder methods, we can represent the union set of A and B, A union B, which is X, such that X belongs to A or X belongs to B. Right? Understand? So thus, if two sets A and B are given, the union of sets A and B is equal to the set that contains all the elements present in the set A or in the set B. Okay, we can write the set A or in the set B. Understand? See here, and this symbol, the union of set is a set which the formation of the combination of sets A and B, that we have to make the such a set, the set another set, and by taking of the set A and B, and that by taking all the elements that present in the set A and in the set B. So this operation can be represented, already we discussed A union B, which is equal to X, such that X belongs to A or X belongs to B. So here OR means what? Here the meaning OR means, this is the operator, and what is the meaning of that? It means that if X is the element of the set A union B, it means the X may be the element of the set A, or X is either present in the set A or is present in the set B. Right? Understand? Or X may be present in both the set also. Is it clear? The operator OR is union stands for the union set, that it is indicates that the element may be in the set A or may be in the set B or maybe both the set. Right? So here X is the element present in both the set A and B, or either in the set A or in the set B. Is it clear? So let's see with an example. Example of union sets. Okay. Suppose if the set A is equal to 1, 2, 3, 4, 5. A simple example I am going to discuss. Suppose A is a set containing the element 1, 2, 3, 4, 5, and B is another set which contains the set what? B is a set we taking, okay, and B is a set having elements 6, 7, 8. Now let's see A union B. A union B means we have to take all the elements of the set A as well as the set B, right? Okay, so 1, 2, 3, 4, 5 union 6, 7, 8. Thus we shall get the union of the sets is A union B, which is 1, 2, 3, 4, 5, 6, 7, 8. This is the the union set of A and B. Okay, so understood? Very simple. We have to take all the element of the A and all the element of B, and by taking all the element of A and B, we have to write in the curly brackets and that brings out the formation of the another set, and that set is the known as A union B. Okay, understand? Very simple. Okay, let's see here. What is the Venn diagram of the set union? With the help of Venn diagram, we can explain also, right? Suppose the set A is equal to 1, 2, 3, 4, 5, 9. Another set B is 6, 7, 8, 9. So A union B we shall get. Understand? So A union B we shall get 1, 2, 3, 4, 5, 6, 7, 8, 9 by taking all the element of A and B. So let's see how to write in the Venn diagram. This is the Venn diagram of A union B. Here you see U stands for, this is the U stands for inversal set. Sometimes please don't confuse in the union set. It is also, this symbol also we can use sometimes the union set, inversal set. Understand? But the set union, and this is known as the set operator. Okay. Now here is the set A and B. Here A union B. This is the A union B, right? Understand or not? So A union B, we have to take the element. Let's see, and it contains the set element. So A is the element what? What are the element of the set A? That is 1, 2, 3, 4, 5. You see the element 6 is an element of the set B. 7, 8, and 9. You see here the 9 is an element, is the present in, okay, the present in both the set. Yes, here this present in both the element. 9 is the element of both the set. That's why it is written in the intersection portion, the common portion, right? So this is the Venn diagram of A union B by taking all the element 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the Venn diagram for you of the set union. Understand? Okay, let's see here another set. If A is a set having element A, B, C, D, and B is an element, B is a set having element D, E, F, okay, and C is another set whose element G, H, K, the 3 set. We can take the union of more than 2 sets also. Okay, understand? Here find A union B union C, and this is the combination of 3 sets. We are taking the union of 3 sets A, B, C. Okay, and here according to definition, the union set means all the element of A, B, C can be taken in the, while you are formulating formation of the union set of A, B, and C. Let's see the Venn diagram here. Understand? Here if you see by A union B union C, what the elements are here? A, B, C, D, E, F, G, H, K. And look at the Venn diagram here. Here it is the set A, set B, and set C. Okay, understand? And here the element of the set. Here you see the element. See what kind of element of the set A? You write A, B, C, D. And here the element of the set B, E, F, yes, D, and here this is the set C, and his element are G, H, K. Understand? So if all the elements are taken, okay, and these are the element of the A union B union C, we have to take all the element of the set A, B, and C. Is it clear? Yes. So this is the A union B union C. Similarly, the properties of union set. What is the properties of union set? First property is that commutative property. Commutative law. As you know, the commutative law of addition, subtraction, multiplication, division in algebra, similar process in the set theory also, we can use the commutative property. We can add 2 sets in any order. Okay, when the 2 sets undergo union in any order, their resulting set remains same. The resultant set will remain same. It means that the union sets obey commutative law. In mathematical term, we can say that A union B is equal to B union A. Okay, the set union obey commutative law. Is it clear? That we are going to prove it. Okay, It means when the two sets can be undergo union in any order, the resultant set will remain same. Okay, this is one of the important property, and we can prove it, we can verify it. Okay, let us see how to prove A union B is equal to B union A here. By taking examples, we can prove it by examples, by using property and by using Venn diagram. Three methods are there, and here I am going to prove it. A union B is equal to B union A by taking the examples. Suppose A is a set having element 1, 2, 3, 4, 5, 6, and B is an element having a B is a set having element 5, 6, 7, 8, 9. So now you see we have to prove LHS, left hand side A union B. So the element of A union B will be the set of all the elements of A and B, and you can see the A union B. Okay, what are the elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. All the elements of the set A and B. Okay, can be taken to form A union B. Understand? Let's see once again. Similarly, we have to find RHS, right hand side B union A. Here the first set is B, second set is A. So you have to write the first set B. The element of the first set B is what? 5, 6, 7, 8, 9 union. Second set 1, 2, 3, 4, 5, 6. If you see similar process, we can take all the elements of the set B and A to bring out the formation of B union A, and you can clearly see, and in both cases it is clearly understood that both the set A union B and B union A having the same element. Thus it is understood, it is proved that the A union B is equal to B union A. It means the set union obey commutative law. Okay, and it is also another alternative methods using property. I have done it by using property. How can you prove A union B is equal to B union A commutative law? We know that if A is a subset of B and B is a subset of A, then A is equal to B in the previous set. Yes or no? So if you can prove that A union B is a subset of B union A and B union A is a subset of A union B, then you can prove that A union B is equal to B union A. Is it clear? Understand? So let's see A union B is equal to B union A using property methods, using builder methods by taking the element X. Okay, we have to prove it. Suppose let X belongs to A union B, and if X belongs to A union B, then if X belongs to A, then X belongs to B according to the subset, because A is a subset of B, right? So X belongs to B or X belongs to A, we can write. Understand? Then X belongs to B union A. It means X belongs to A union B, then X belongs to B union A. It means A union B is a subset of B union A. Understand? Okay. Since X is an element of A union B, then X may be an element of the set A, or then X must be element in the set B. Then, or you can write if X belongs to B, then X also, or X belongs to A. Okay. Then X belongs to B union A. Understand? Since X belongs to A union B and X belongs to B union A, thus A union B is a subset of B union A. Okay. Similarly, we can prove it. Let X belongs to B union A. If X belongs to B union, X belongs to B, then X belongs to A, right? X belongs to B union A means X belongs to B, then X belongs to A. It means X belongs to A or X belongs to B. X may be an element in the set A or in the set B, because union set, the element in the set either in the set A or in the set B. It means X belongs to A union B. Thus, since X belongs to B union A and X belongs to A union B, also this is clearly understood, so that B union A is also subset of A union B. Understand? Okay. So from both the cases, we clearly that A union B is a subset of B union A from the point 1. Again, B union A is a subset of A union B, point 2. So from both the cases, it is clearly understood that A union B is equal to B union A. It means using the property method, and it is also proved the set union set obey commutative law. Understand? And also we can use the Venn diagram to prove this. Okay. Let's see A union B. The element A is a set and B the Here we have taken the A set and B set, and here is the set A union V element, and in this process we can find the Venn diagram, how to find the union set A union V. We can prove commutative law under union set. Okay, here two sets A and V. Now write down the element of the set A and V in the Venn diagram. These are the element of the set A, yes, and these are the element of the set V. Clear? So A union V, you see all the element of the set A and V we have taken to bring the formation of A union V, right? Understand? So let's see more clearly the A union V. The shading region, the shading portion, the shaded portion which covers the entire parts of the set A and V. Okay, the part of the region of A and V entirely taken considered. Okay, as A union V, this is the by shading portion, shaded portion of A and V. Okay, also clear that it is the Venn diagram of A union V, which is the part of entire part of A and V. Okay, understand? So A union V is the shading portion of A union V, right? Okay, all the element of A and B. It is clear the shading region indicate that we have to take all the element of A and all the element of B to bring the formation of a new set, that is known as A union B. And from the Venn diagram also it is clearly understood, right? Okay, understand? Okay. Similarly, B union A. Let us take first set B, second set A. Let us write the element, and 5, 6, these are the common element which are present in the set A and V. Here 7, 8 are the element of the set V. Okay, 9. Similarly, these element of the these are the element of the set A. So B union A, we can take the B union A which by taking all the element of B and element of A. Understand? Same element contains, right? Okay. From both the cases it is clear that we see the B union A is also by taking the set B and A. Okay, let's see the shading portion, the shaded portion, the shaded region indicate that we have to take all the element of B and A to bring out the formation of B union A. See, both the cases A union B and B union A give the same Venn diagram, and from the both Venn diagram it is clearly understood that A union B is equal to B union A. Thus, the union set obeys commutative law, and which has been proved by Venn diagram. Okay, students? Yes? Right, look at A union B is equal to B union A. Here B union A, right? So, next property of the union set, important property. Okay, property number 2, very simple. A union phi is equal to phi union A, which is A set. It means if you take any set of union set of phi set, A is a non-empty set and it is a null set. Okay, the union of non-empty set and phi set is also the set itself, A. Understand? The union of any set with the empty set is always the set itself. For example, let's the set A is equal to ABCD and A union phi what? Okay, which is same set A. And similarly phi union A union phi is equal to A set. Okay. Similarly, if you take phi union A, also A, thus we get A union phi is equal to phi union A. Yes, which is the set A. This is also another fundamental properties, okay, of the union set. Thus, union set, union of any set with the empty set is always the set itself, right? Now, the property of union set, another property also you see, A union A is equal to A. It means the union of every set is the set itself, right? Yes. Another property is that, property 4, if A is a subset of B, then what would the A union be? Yes, A union B is equal to what? B. Yes. if A is a subset of B, then A union B is equal to B. This is another property. For example, suppose A is a set which is containing element ABC, and B is an element, B is a set, B is not element, B is a set whose element are here. Clearly you see A is a subset of B. Yes or no? If all the element of A are in set B. Thus A is a subset of B. Thus we find A union B, which is set. The A union B is set. The set B. Thus A union B, okay, is equal to B set. If A is a subset of B, the A union B is equal to set B. Clear? Understand? Okay, and very simply and very easily and lucidly, and you can understand this concept. And if A is a subset of another set B, then their union set is the superset. Our set, superset, yes. Yes. Another important property is associative property. As the binary operation, that is the associative of addition, subtraction, multiplication, division. Similarly, in set union also, we have to explain the associative property by using example, by using property, by using Venn diagram. We can explain. And when three sets undergo union in any order, the resultant set always remains same. This is called associative property of set union. It means A union B, whole into A union B, whole into union C is equal to A union whole into B union C. This is the associative law. It means the associative property of union set. Okay, it means the union set follow associative property. Okay, right? So we have to prove it by giving example. How to prove example? Whole A union B union C is equal to A union whole B union C. Okay, understand? Right? Let's see here. Let's see, student, you have to a little bit, these are the very simple concept. Let's see. Okay, develop patience to watch this class. Let's see how to prove the associative property of union set. So taking example, let ABC are the any three sets. Here A is a set, element have been taken. Here these are the element of the set V. Here these are the element of the set C. We have to take the three sets, three non-empty set, right? We have to prove it. A union B whole into whole A union B union C is equal to A union whole B union C. For that, let LHS left hand side whole A union B union C. First of all, see now the element of A written 1, 2, 3, 4, 5 union. The element of B are 4, 5, 6, 7, 8 and union. See, first of all you have to find out A union B, right? And A union B, what are the element? All the element of A and B, which is 1, 2, 3, 4, 5, 6, 7, 8 union C set elements, which are the 7, 8, 9, 10. First of all you have to find out A union B. After finding, you shall get the resulting set. You have to find out union C. And these are the you will get A union B union C. Look at here. Thus we get A union B whole A union B union C. Okay. Look at the element. What kind of elements are there? By taking all the element of A union B union C. First of all, you have to find out the unions of A and B. Then with the resulting set, you have to find out union set C. Okay. Understand? Let's see RHS A union whole B union C. First of all, you have to find out the union set of B and C, because B and C are under the bracket. So you have to use the bracket work first as per the rule. So here A union B union C, you see clearly also same element. So A union B, whole B union C also element, the same element they have. Okay, which is 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, 10. So these are the element has been repeated. If the elements are repeated and they are the same element, yes, understand? We can also write that set here. Understand? Yes. Here you can write. Okay, all the element you see, and hence we clearly understand LHS, you will RHS. Here the elements are repeated, and you know if the elements are repeated, they are considered as the same element, right? Here 1, 2, 3, 4, 5, yes, 6, 7, 8, 9, 10. This is the element set. Okay, and this is the equation number 2 we got. The elements are repeated and the set do not vary. Okay, and it's clearly understood that both LHS are equal to RHS. Thus, it is also proved the whole A union B union C is equal to A union B union C. It means the union set obeys associative law. This is the we can prove it as law property by using example. Also, we can prove by using Venn diagram. Look at the Venn diagram here. Interesting Venn diagram for you. Look at the diagram here, and you see here the set A, here the set B, is another set C taken. Understand? Okay, we have to see first element A union B. Look at here, the elements are written of this. Yes. So what are the element you have to write within the same Venn diagram? You see these are the element, these are region of the set A. The element are 1, 2, 3, 4, 5. Okay. So let us you have to write down the element. Thus A union B, whole A union B union C. Look at here. This set you are taking. Yes. First you have to take A union B. A union B means all the element of A union B you have to take. The shading portion of A union B, all the element of A and B. Okay. Understand? So these are the element of what? A and B. Okay. Then after that you have to take the shading portion of union set C. Okay. Right. The entire shading portion, can you understand, is the element of A union B union C, right? Understand? You can take all the same element also, you can take here. Also you can take this element also, can be taken as the set. These also can be taken, all the set, right? Yes. So these are the shading portion of A union B union C, right? And finally we shall get the resultant set. You clearly understood the whole entire region of A, B, C, three sets, shading portion C. Yes. Okay, this is the whole A union B union C. Understand? Look at the interesting Venn diagram for you, right? Okay, and we shall get now RHS. Let's see what is RHS. Look at the diagram here, Venn diagram. You have to take first B union C, because B union C in the bracket. Okay, then you take the union of A. Understand? Yes. Okay, and finally get and this side is A, this side is A. So entire shading portion of ABC finally is clearly understood that in both the cases LHS equal to RHS. Right? Okay. Understand? Yes. Okay. And from both the Venn diagram it is clearly understood that the set obey associative property under the union set. The set union obey associative law. Look at more clearly the Venn diagram can be understood. The associative property of union set. Okay. So please don't leave the class. Look at the class with patience. Very interesting and very easy class for you, which I am going to prepare with interesting Venn diagram for you, for your interest, for your understanding. Okay, and you clearly understand. There will no doubt for you. I hope it is my confidence to you. Okay, so you can clearly understand the concept of the associative property. How can we explain with the help of the Venn diagram, and thus the set union of a associative law. Okay, understand? Is it clear? Yes? Understand? Once again look at. Okay. Similarly, another, we can prove it. See, how can we prove it? Using property also. See how the different methods we can use to prove the concept and property of set theory. This is very important. See, I have prepared for you in every concept and for your understanding. These are most different methodology which is most inevitable. You should know different methodology you can, what kind of different methodology can be used and in solving any mathematical problem process, and what are the different process methods we are using. That is the most important factor of the understanding about the math. Not only particular concept, what are the different, to explain a concept we have the different process, what are the methodology you are using. So it is, understand, so that you have to develop patience and also you have to develop interest toward the class. Okay, once you are the passion of mathematics, so it means you will imbibe, you will forget everything and also you will keep on practicing mathematics. Okay, so very important concept, interesting concept. We are going to prove the associative property using property method, and all of you know that if A is a subset of B and B is a subset of A, then A equal to B. Two sets are equal if A is a subset of B and B is a subset of A. Very simple concept in the first class. Okay, while discussing the property of the subset, in the same subset we can use to prove the associative property. Understand? If you can prove A union B whole union C is a subset of A union B whole B union C, and we can prove A union whole B union C is a subset of A union B whole A union B union C, then you can prove whole A union B union C is equal to whole A union B union C. It means using property method, these two conditions we have to verify. If these two conditions is verified, then we can prove it the associative law, the set union of a associative property, right? So let's see. Okay, how. First point, we have to prove A union B union C is a subset of A union whole B union C. Let X belongs to whole A union B union C, right? It means X belongs to A union B whole A union B, or X belongs to C. It means X belongs to whole A union B or X belongs to C. Understand? And X belongs to A union B means already know, according to builder methods, set property methods, X belongs to A or X belongs to B or X belongs to C. We can rearrange. If X belongs to A or X belongs to B or X belongs to C, we remove the bracket. Understand? Okay, again you see, rearrange. After rearranging, X belongs to A or X belongs to B or X belongs to C. Here we have rearranged this one. This one has been rearranged. Understand or not? After rearranging, we will get, thus we get X belongs to A or X belongs to B union C. Understand? Yes? A union B union C what? Okay? Or X belongs to A or X belongs to B union C. It means X belongs to A union whole B union C. It means since X belongs to whole A union B union C, then X belongs to A union whole B union C. It means it is clearly proved that A union B whole A union B union C is a subset of A union whole B union C. Understand? Yes? Is it clear, this concept? Okay? And the point one, similarly we can prove what also, we can prove it on the A union B whole B union C is also subset of whole A union B union C. Okay? Similarly, let us take X belongs to A union whole B union C. It means X belongs to A or X belongs to B union C, right? Or X belongs to A or whole X belongs to B or X belongs to C. Because B union C means what? the B union C means, yes, here B union C means, okay, look at X belongs to B or X belongs to C. Okay, if you remove the bracket, you will get X belongs to A, this line you see, X belongs to A or X belongs to B or X belongs to C. Then you have to rearrange this one. This one you have to rearrange. After rearranging, you will get X belongs to A or X belongs to B or X belongs to C. Okay, it means X belongs to A union B. Okay, X belongs to A or X belongs to B, it means X belongs to A union B or X belongs to C. Thus we get X belongs to A whole A union B union C. Thus X belongs to A union whole B union C. Since X belongs to A union whole B union C, and also X is an element of whole A union B union C, and from both the cases it is clearly understood that A union whole B union C is a subset of A union B union C. Okay, so from both the points, from equation 1 and 2, it is clearly understood that A union B whole A union B union C is a subset of A union whole B union C, right? And A union whole B union C is also subset of whole A union B union C. Thus, the union set obeys associative law from both the cases. This is the property methods using we can prove an important statement of the union set, that union set obeys associative property. Understand? So let's recapitulation of the property of union set. These are the important points of the union set. We'll discuss. Let us recapitulate. Okay. If two sets A and B are given, then union of A and B is equal to the sets contains all elements present in A and in the set B. Second property already discussed. This operation can be represented as A union B is equal to X such that X belongs to A or X belongs to B, where X is present either in the set A and B or both the set A and B. And set union obey commutative property already discussed. We prove it by three methods: by taking example, by property, and by Venn diagrams. Okay, understand? Okay, the set union obey commutative law, and already discussed A union B is equal to B union A. It means, yes. And another property already discussed. Remember this, students, and the property union of any set with the empty set is always the set itself. A union phi is equal to phi union A is A set, and A union A is equal to A set. Every set, any set, the union of any set with itself is also the set, same set. Okay, if A is a subset of B, then A union B is equal to B. And union set obeys associative law. Already you prove it by three methods: example, by using property, and by Venn diagrams. Okay, and set union obey associative law. Whole A union B union C is equal to A union whole B union C. It is proved. Thank you. And here is an assignment for you. Assignment 1. I hope you will try for the assignment. Here I have prepared some assignment for you, homework for you, which is necessary. Here is the assignment 2. Okay, and you can do it using the concept of operation of set theory. Here is the assignment 3. Look at the assignment here. Here is the problem based on the concept of union set and intersection set. There is another assignment 4. Okay, over the same concept, and the assignment 5. Okay, so I hope you have understood, and I must be thankful for your interest and eagerness towards your class. Okay, once again thank you for your interest and eagerness towards the class. Okay, I hope, and you will give your suggestion and feedback. Okay, and also you will practice the similar kind of problem, and also you will try for the assignment. Once again thank you. Jai Jagannath.